Let's take a journey deep inside this apple. Eventually, the further we go, we'll reach a molecular level. And if we go inside those molecules, we'll see atoms. Within those atoms, inside the nucleus composed of protons and neutrons, there are smaller particles like quarks, which are said to be the building blocks of the universe. But what if I told you we could go even smaller? This leads us to string theory, which states that everything is made up of tiny vibrating one-dimensional strings rather than point particles like quarks. So essentially, these little filaments of energy are what makes up the world around us and what makes you, well, you. But how exactly do these strings work? You can think about their function similar to that of a guitar. Each time I strum a note, it gives us a certain sound, and when I strum a different note, it gives us a different sound. This is how the strings in string theory behave as they correspond to a different elementary particle, each vibrational pattern, like quarks or electrons. But there's also something major that makes this concept revolutionary. String theory combines general relativity, which deals with the really big, like the warping of space-time, and quantum mechanics, which deals with the very small on a subatomic scale. These two have been incompatible since quantum mechanics only accounts for 3 of the 4 fundamental forces of nature: strong and weak nuclear forces and electromagnetism, while general relativity only accounted for gravity. Gravity was left out of the standard model, so we never really achieved unification. But string theory does just that and finally unites all 4 forces, giving us a singular theory for how the universe works. So string theory seems like the perfect candidate for unification. However, it does require 10 dimensions in order for the math to work. Well, we know the 3 dimensions we live in, including left to right, back and forth, and up and down. We also know the 4th temporal dimension of time. Since we can only visualize these dimensions from our point of view, how can we see the others suggested in string theory? Well, it's not quite physically possible. For example, when you look at my flute from far away, it looks like a linear one-dimensional line, with the only possible directions being left and right. But from my perspective, you can tell it's 3-dimensional, since you can find its height, width, and depth. This is similar to how the strings appear, which means these extra dimensions in strings are just way too small and distant for the human eye to see. To identify them, we need a particle accelerator much bigger than the Large Hadron Collider, one that's the size of our galaxy. Although string theory isn't perfect, we're only getting closer to finally proving a grand unified theory, the long-sided theory of everything. We're only going forward from here on this road to unification.